This is an introduction to quadratic functions, and in a little bit, another video, we'll talk about how to graph them. But some of the key features of quadratic functions: number one, they have an x squared in them. Like x squared, then x, then no x. But the key is this is squared. This is a quadratic function here. Notice that in the formula that they give you in the description, maybe in your book or with your instructor, they say A, B, and C are the constants. Well, that means that whatever number is with the x squared, we call that A. So in this case, A is -3. And there's a key to this. These other numbers, it doesn't matter, but that first one, A cannot be 0, because if it was 0 and you plug that in for x, if it was 0 and you plugged it in here, it would say 0 times whatever is here, and it would cause this to cancel out. It would be 0, and there would no longer be a quadratic function because it doesn't have the x squared value in there. So A cannot be 0, okay? But it can be any other number. It can be -3, it can be 100. Any positive or negative doesn't matter, but the numbers that are attached to the letters here with multiplication. The A in this case is -3, the B is a +8, and the C is a -2. So you want to keep in mind A, B, and C are just the numbers, the constants that are sitting next to the letters or standing alone as a constant out here. That's what a quadratic function looks like. Now, there's some features to how you graph this, and it turns out that if you have an x squared here as a quadratic function, when you graph them, they make what we call a parabola. So x squared being a positive number out here, this would cause this to be a U shape, which is a parabola, a U shape that points up forever in the positive direction. So if it's positive next to it, then it's going to point in the positive direction. And if it's negative next to the x, like this one here was negative, so the parabola would point down, that it would point into the negative region forever and ever, infinity. So a parabola that has a positive number here, if it doesn't have a number, it always has that invisible 1. So this is a +1, and this is a -1. So this one points up. If it had said 8x squared, it would still point up. It would just change the position on the graph, but it would still look like this. This one down here, this has -1, it's pointing down. If it said -3, it would still point down. Where to put it on the graph is another thing, but just know that general idea, that no matter what your problem looks like, if the x squared is positive, then it's going to point up. Some other features about the graph that when you draw it. When you draw this, if you cut it in half vertically, that's called the axis of symmetry. Symmetry means that you're cutting something where both sides look exactly the same, so you're cutting it perfectly in half vertically here. So the axis of symmetry is that invisible line. I put it on here in orange and yellow, but normally it's just, a U that you see and you have to visualize. If there was a line going straight up and down in it, that would be our axis of symmetry. Notice how this U, for the positive x squared, again, it has a bottom and then it points into the positive direction for infinity. Well, because it has a bottom to it, there's a place that it stops down here. This thing is pointing up, so it says concave up. It's pointing up. But it has a low spot, and so it has the lowest spot, which we would call the minimum. It has the lowest value that can possibly be used for this. Also, that lowest spot is also known as the the vertex. So if they ask you to find the minimum, they mean find the vertex. And so the vertex, I put a dot here to show you it's the lowest spot. It wouldn't normally show you a dot there. You would have to do the math to find out what the name of this spot is. But that's the spot they're talking about when they talk about vertex. So for these parabolas, this one, since it's pointing down, it's called concave down. It's pointing down forever. It's because it was a negative value in front of the x squared. And so notice that it goes down forever, but it does have a limit going up, like the highest point is here. And it's also the vertex. The vertex is its highest point.